For this video here, we're going to work on our graphs. So let's start by graphing situation A. Okay, so if you look at situation A, notice this here, this has a positive velocity and a positive acceleration. Okay, if y'all remember, anytime the sign of our velocity matches the sign of our acceleration, that means the object is speeding up. Okay, so positive velocity, positive acceleration, same signs, that means we're speeding up. So in this case, we're speeding up in the positive direction. So how does it look like on a position time graph? So on a position time graph, again, we're working on situation A here. If we're speeding up in the positive direction, that means we're going uphill and we're becoming steeper with time. So your position time graph should look something like this for situation A. Goes uphill and it becomes steeper with time. Your velocity time graph, you should be on the positive end and you should be getting further away from zero. So that should look something like this for a velocity time graph. And by the way, if you guys come over here, you notice here that our instantaneous velocity here is 3 meters per second. So in order to show that on my graph, I'm going to come over here and you see 3. Right there where you see a velocity of positive 3 meters per second, that means I'm at that point right there on my graph. So I would highlight 3 meters per second right there. Okay. So my instantaneous velocity is 3 meters per second. Now, what about our acceleration? All right, so if you come over here, you notice the acceleration here is 2 meters per second squared, positive 2 meters per second squared. So I'm going to come over here to my graph, and I'm going to draw a straight line through positive 2 meters per second squared. Okay? So that's how your graph should look like for situation A. Remember, for these graphs, you need to be very specific about your velocity and very specific about your acceleration. In this case, as the elevator is speeding up in the positive direction, my instantaneous velocity at a specific point is 3 meters per second, which is what these pictures show. They show instantaneous velocity at a specific moment in time. Okay, so let's move on to B. Okay, so looking at B here, okay, so this is situation B. Okay, in a situation B, I have a positive velocity and a negative acceleration. And you can see that's negative there because that arrow is pointed down. So a positive velocity for situation B, positive velocity and a negative acceleration. If you notice here, my signs are different. So anytime I have different signs, that means I'm slowing down. So this object here is slowing down while moving in the positive direction. So how does it look like on a position time graph? Okay, so let's come over here. Okay, so for situation B, if we're slowing down in the positive direction, once again, our graph needs to be curving uphill, but now it needs to be getting flatter with time because it's slowing down. So our position time graph looks like this. Okay, so it's going uphill and it's flattening with time. What about our velocity time graph? For velocity time graph, if you're slowing down in the positive direction, that means you're on the positive side, and that means you're becoming flatter with time. So start somewhere over here. I'm sorry, you're on the positive end and you're approaching zero. Right, so we need to be approaching zero. So we're on the positive end and we're approaching zero. If you notice here, our instantaneous velocity here was 3 meters per second. So I'm going to come over here, and I'm going to show that. Hold on, let's go back to B. Yeah, so our instantaneous velocity here was 3 meters per second. So for B, it's our instantaneous velocity. I'm going to come over here, and I'm going to represent that 3 meters per second is somewhere around here. So I'm going to represent that on my velocity time graph, my instantaneous velocity, my velocity at a particular moment. Okay, so that's our instantaneous velocity. It's at 3 meters per second. And lastly, look at our acceleration for B. The acceleration is negative 2 meters per second squared. So I'm going to come over here. Okay, so I'm going to come over here, and I'm going to do a straight line through negative 2 meters per second squared. And that's my acceleration. Okay. So that's how your graph should look like for situation B. Okay. Now, let us move on to situation C. Okay. So in situation C, okay, if you notice, my velocity is positive 3 meters per second. And what is my acceleration? My acceleration here is 0. Okay, if you guys remember, acceleration of 0 means I'm moving at a constant velocity. So how does a constant velocity look like on a position time graph? Okay, so come over here. Constant velocity looks something like this. Here's a constant velocity. It looks something like this. That's a constant velocity of 3 meters per second, where it's understood there that the slope of this line will be 3 meters per second. But you just need to do a just straight line going upward to represent a constant velocity, and that will suffice for this problem. And then how do I represent, so that's how a constant velocity looks like on a position time graph. How do I represent a constant velocity on a velocity time graph? So here the constant velocity is at 3 meters per second, and it's positive. So I need to come over here, and I need to do a constant velocity at right there at 3 meters per second. So notice I'm right here at 3 meters per second, and it's a constant velocity. And lastly, a constant velocity by definition means my acceleration is 0. So if my acceleration is 0, I just come over here and draw a straight line through 0. Okay, so that's my acceleration. Okay, let me kind of make that a little bolder for you guys. So a straight line right through 0. So a bold straight line through 0 meters per second squared represents 0 acceleration. Okay, so that's A through C. I'm going to stop this, and I'm going to do another video for D through F.